In far-off galaxies, galactic invaders are at work. 3 times daily, a strange flash pulsates across our sky. It is hundreds of times stronger than all of the world's nuclear weapons put together. But it wasn't made by people, and if one happens close enough to Earth, it could wipe out all life there. Most people on Earth don't know about the possible dangers in space. Imagine this. A huge star explodes in our galaxy, the Milky Way, sending a deadly burst of energy hurtling toward our planet. This is a gamma-ray burst, which is the biggest blast since the Big Bang. There are no signs that something bad is about to happen, and then it strikes. The radiation that is pumped up heats up the high atmosphere. Our layer of ozone heats up. Across the atmosphere, human beings burns to death from radiation 100 times the fatal dose. When the ozone layer gets thinner, temperatures rise all over the world. This makes storms, tsunamis, and hurricanes happen. Most life on the surfaces of land and water incinerates. This may sound like science fiction, but if a gamma ray burst from 100 light years away hit Earth, it could happen. Gamma ray bursts are the most bright blasts in the universe. They must have a huge amount of power because they're so far away and yet still so bright. As much energy as the sun will give off in its full 10 billion year life. We know there are many planets and many stars in the universe, so gamma ray burst could have wiped out a lot of different cultures. In the 1960s, this strange blast of radiation was first seen. At first, because these gamma ray bursts are so bright, most scientists thought they came from our own galaxy, the Milky Way. There are a few reasons for that. One of them is that if they are outside the galaxy, the energy is almost too much to believe. But back then, even the most powerful telescopes couldn't figure out where they were or how far away they were because the burst only lasted a few seconds and then went away. But then, scientists started to wonder about their afterglow. Most blasts in space leave a glowing trail behind that can last for days or even weeks. In the late 1990s, satellites with better optics and X-ray monitors were finally able to catch the afterglow of a gamma-ray burst. It became clear that gamma-ray bursts actually came from outside our galaxy, millions and billions of light years away. So, their power had to be really out of this world. The brightness of the gamma-ray burst is the same as that of 1,000,000 trillion suns. This huge explosion could wipe out all life on Earth. But why do they happen? We are very sure that a common gamma-ray burst is caused by the death of a star that is at least 10 times the mass of the Sun. And these kinds of stars aren't very common. When a very big star dies, it falls apart and forms a black hole. Black holes are made when a mass of matter shrinks to a point where it is so dense that light can't get out. But experts think that some of the star resists getting sucked into the center of the black hole. As a result, a high-speed spinning disk of matter forms around it. In a matter of seconds, plasma jets shoot out from the poles where it spins. These beams of energy unleash dangerous gamma rays into space. At the same time, the gamma-ray bursts are ejected, the collapsing star explodes or goes supernova to the extreme. Gamma-ray bursts are so bright because they take a huge amount of power and focus it on a very small area of the sky. Only one of every 300 gamma-ray bursts is directed toward us, so we only see one of those 300. Even if a gamma-ray burst happened not 100 but 1,000 light years away, the Earth could still be destroyed in a way that is similar to the end of the world. If a gamma-ray burst happens within 100 light years off the Earth, then it would be approximately 500 times brighter than the Sun and made in gamma rays. The energy sent to the high atmosphere of Earth would be the same as if 100,000 megatons of nuclear bombs went off. The ozone would be depleted, we'd have acid rain, but we'd also have flash burns, incineration of vegetation, perhaps something resembling nuclear weather. So many species could go extinct all over the world. Now, the other side of the Earth would be a special place to be, because gamma rays don't go through the Earth, so you wouldn't get flash burned if you were there. However, the repercussions of altering the atmospheric composition and ozone depletion would ultimately come to the other side, and there, nobody knows what will happen. This nightmare scenario has a 1 in a trillion probability of occurring once in Earth's history. It's going to be a nasty day if you get caught in the beam, for the reason that this is extremely powerful radiation. You don't want to be in the vicinity of this sort of energy, since it has the potential to break down your own molecules. Currently, there is no way to protect humanity against gamma-ray bursts that occur in close proximity to Earth. They move at the rate of 186,000 miles per second, or the speed of light. By the time we detected them, they would have already struck our planet. Gamma rays bursts could pose a hazard to the Earth or to anything living that came within their born sight. Astronomers think that gamma ray bursts could be the cause of some mass extinctions on Earth. The one that happened 450 million years ago and killed off the Ordovician and Silurian species was probably the worst. Creatures that lived near the surface of the ocean were hit much harder than those that lived deep in the ocean. This is consistent with what would happen during a strong gamma ray burst. In a galaxy the size of the Milky Way, gamma ray bursts happen about once every few 100,000 years, according to astronomers. Even though they can be very bad, you have to be pretty close to be hurt by one. A gamma ray burst happens about once every 5 million years, which is close enough to affect life on Earth. In other words, since the Earth was made 4.6 billion years ago, there have been about 1,000 events. So the chances of a close gamma ray burst aren't zero, but they're low enough that you don't need to worry about them, unless you want to live for about 5 million years. Humanity obviously made it through the gamma ray explosion unharmed, but this still demonstrates how far their effects may travel. Don't fret. Threats to Earth from gamma ray bursts are extremely low. All of the closest contenders for gamma ray bursts have been studied by astronomers, and none of them are either close enough or orientated in a way that would cause them to strike Earth. Therefore, what do you think? In our solar system, Earth shines like a sapphire jewel. We go about our daily lives without knowing that trouble could be coming from deep space. The routes that Earth and most other things take around the sun can be predicted. Most of the time, things are quiet and easy, but sometimes they get crazy and violent. Earth can be hit by space rocks, zapped by dangerous space weather, jolted, jostled, and threatened by the object's energy and cosmic forces. The Earth is on a wild ride through space that is often very dangerous. When you're moving fast in on a predetermined path, you hope nothing crosses because there's nothing you can do. Rusty Schweickart used to be an astronaut, so he knows how dangerous things in space can be. During the Apollo 9 flight in 1969, he was in charge of the lunar module. He is sending out warnings about the risks of an asteroid named Apophis that is getting too close to be safe. Everyone noticed him right away because the probability of impact was quite high. In fact, it was significantly greater than any effect probability we had seen before. Schweickart has a scary example from real life that shows how bad an asteroid, even one smaller than Apophis, can be when it hits. June 30th, 1908, 7:15 a.m. A half-football field-sized object came hurtling down from space at about 34,000 miles per hour and made a stream of fiery gas behind it. Within minutes, The fireball hit Earth's atmosphere and burst violently near the Tunguska Forest in Siberia. As a result, the explosion was the greatest ever recorded in the history of the planet. The explosion split the waves, which then set fire to 8 million trees in an area that was bigger than half of Rhode Island. Because the explosion happened in a place with few people, no one died directly from it. If that asteroid had hit just a few hours later, it would not have hit Siberia, but Europe. And if it had exploded in the air over one of Europe's biggest cities, 1 million people would have died. For the last 100 years, the Tunguska explosion has been shrouded in controversy. Many researchers now think an asteroid was the explosive trigger. Incredibly, it never even impacted the ground. Rather, it exploded 5 miles above Siberia's frozen ground. When it smacks into the lower atmosphere, doing about 50,000 miles an hour, it's like an egg smashing on the concrete. Energy equivalent to 15 megatons of TNT was released in the Siberian explosion, making it 1,000 times greater than Hiroshima. Over a huge city, this would be catastrophic. NEOs, or near-Earth objects, were the name given by scientists to these trespassers. They are comets and asteroids, leftover debris from when the planets formed. The Oort cloud is a part of the Kuiper belt that extends past Neptune and is where comets travel. Between Jupiter and Mars, asteroids take a curved path, but their orbital trip isn't always routine. We don't have to worry too much about asteroids because they circle in a somewhat orderly belt between Mars and Jupiter. But when one gets away and all that mass and energy is going toward Earth, that's when the astronomers start to worry. It's not uncommon for cosmic debris to be jolted out of orbit and headed for Earth. The majority of it is evaporated by our planet's dense atmosphere. A larger object, however, is able to break through Earth's atmosphere and crash to the surface. Asteroids are a real and dangerous threat if you wish to look to the cosmos for the powers that would have us dead. Just like it did previously, it will happen again. 65 million years ago, an asteroid the size of a small city plummeted down from the sky. It exploded in the Yucatan Peninsula, near the town of Chicxulub in Mexico, with a force of 100 million megatons of TNT. Here we see Earth hurling billions of tons of its crust into space, creating a blanket that blocks out sunlight, destroying the food web at its roots, and killing off countless species. The ferocious impact is thought to have been a factor in the extinction of the dinosaurs. We can think of asteroids as being bad things, but if it were not for an asteroid, we wouldn't be here today. Our mammal ancestors were running on their foot trying to avoid being appetizer for T-Rex. T-Rex gets taken out. Well, this opened up an ecological niche that allowed our mammal ancestors to evolve to something more ambitious than a route and outcomes the primates, and among the primates, we have people. But it's strange that the same kind of cosmic boulder that made it possible for humans to live could one day wipe us out. In 1998, Congress asked NASA to find all near-Earth objects that were at least half a mile across, and what they found was unsettling. There are more than 850 NEOs near our vicinity. These asteroids are our nearest and most dangerous space friends. Finding these near-Earth objects is a bit like keeping an eye on storms. As you watch it day after day, you get a better idea of its path and can figure out where it's going, how big it is, and how fast it would hit the Earth if it did. By using telescopic technologies, NASA's SpaceGuard survey has detected over 90% of all near-Earth objects deemed harmful. These scary things could hit Earth with more power than all of the nuclear weapons on the world right now. Such an impact could trigger mass extinction. We wouldn't expect one to hit every few hundred, thousand, or millions of years, but if one did, it could wipe out different parts of the population. So there are events that happen very rarely but have big effects when they do. If they hit Earth, they would have impacts all over the world. They would not only wipe out a continent with very strong shock waves, but the debris would also be thrown into the air and land all over the planet, heating the air to 1,000 degrees. And all the vegetation all over the world where that happens would flash into flames. Smaller objects could also cause disasters. So Congress has asked NASA to fund all NEOs with a diameter of 500 feet, which is as big as the Colosseum in Rome. A big object like that could wipe out a city or even a small state. Scientists are most worried about the asteroids they haven't found yet, not the ones they have found. Well, at the moment, there are about 2,000 objects that we can't say for sure won't hit Earth. We now have the technology to keep near-Earth objects from ever hitting Earth again. We can now literally start to change the local solar system to make it better for our life. The question is whether or not we will end up like the dinosaurs. It's hard to believe that the Earth has been around for more than 4.5 billion years because it's been through a lot since it was born. Asteroids that come into our orbit every year keep hitting our world like a boxer, but one day Earth could be knocked out. We've learned that near-Earth objects fly by us all the time, and we're getting more and more able to change our surroundings to help us stay alive. A rock in space named Apophis. In 2004, this pockmarked rock about 750 feet across came close to Earth. Now, it's scheduled to pass dangerously close to our planet again on Friday the 13th in April 2029. So, in 2029, Apophis will get closer to us than our Rome communication satellites that circle the Earth. If you are in the right place, you will be able to see Apophis pass by the Earth with your own eyes. That's how close that rock is going to get. You won't even need binoculars. Over 99% of the time, Apophis will miss the Earth in 2029. However, if it passes the Earth at an exact distance of 18,893 miles, it may pass through a gravitational keyhole, a small area in space that is only a half-mile wide. If this happens, Apophis could be thrown off by the Earth's gravity, which could change its path. It could make Apophis come back and hit Earth on April 13, 2036, 7 years later. The gravitational effect of the Earth would cause it to bend, cause the Apophis's orbit to enlarge to precisely the size, which 7 years later, it will come around and hit the Earth. At the present time, Apophis has 1 in 45,000 chance of delivering a deadly blow in 2036. It's one thing to say that there's a 1 in 45,000 chance that it will hit the Earth, but what you really want to know is if there's a 1 in 100, 1 in 10, or 1 in 1 chance that it will hit the Earth. We have to look at Apophis the same way we look at any natural disaster. You know the date of the hit, when it happened, and the angle of the orbit, so you can make a map. It starts in western Siberia, cuts across and down the Pacific Ocean near California, goes through Central America, and ends in Western Africa. Scientists have come up with a scary idea about where Apophis could strike. With a force of more than 1 million megatons of TNT, the asteroid could hit the Pacific Ocean off the coast of California. Such an impact would make a hole in the water 5 miles wide and 9,000 feet deep. This would cause tsunamis with waves up to 50 feet high to hit the coast, resulting in unimaginable human loss. If a rock 1,000 feet across hits the ocean, that's not a good thing. For that kind of thing, scientists are working on ways to stop such a cosmic strike from happening right now. A possible plan is to blow up an asteroid. But some people worry that this could make the problem worse by sending more pieces of the asteroid our way instead of just one. So, the new goal for experts is to change the path of asteroids that could hit Earth. Change its velocity by a 10,000th of a mile per hour so that it will miss the Earth instead of hitting it. If we know about an asteroid far enough in advance, we can change its path. Although a space probe has landed on an asteroid in the past, the most challenging idea is launching a manned mission. Once landing on the rock, astronauts could mount a radio transponder to track its whereabouts. Now, the United Nations plans to draft a treaty which will include who will be responsible for deflecting killer asteroids. If we are so careless that we keep doing nothing even though we know this is going to happen, that will be a real crime. Any asteroid hitting the Earth will require international disaster response. In addition, training is required in disaster and emergency management institutions and the public regarding the asteroid threat. It is important that everyone is aware of the level of threats and the potential to eliminate this threat. Apart from all these, amateur astronomers can work together with scientists to defend our planet. Amateur astronomers can help identify smaller and potentially destructive asteroids hidden in the universe. So would you like to be an amateur astronomer? Who knows? Maybe you can be one of the guards of our home. On a night in early September 1859, people all over America could see the aurora. It was blood red and so bright that when miners in the Rockies came out of their tunnels, they thought the sun was coming up. So bright, in fact, that even at midnight you could read a newspaper. It didn't just happen in the US. People all over the world saw these auroras. No one knew why they had happened. But earlier that same day, an astronomer had seen something on the sun's surface that he called a white light flare. Back then, the flare and the aurora seemed to have nothing to do with each other. But we now know that the spectacular aurora was caused by that flare, which was a coronal mass ejection. And if this violent event happens again, it could destroy our modern technological world. The sun is the most familiar thing in the sky. It gives all life on Earth heat and light. It is so big that it's hard to imagine, and it makes up 99% of the mass of the solar system. This nearly perfect sphere has a diameter of 1.4 million kilometers and was made by the burning of hydrogen and helium for the last 5 billion years. But from an astronomical point of view, it's nothing special. A G main sequence star, also known as a yellow dwarf. But looks don't always tell the whole story. Solar flares and explosions of plasma, particles, and radiation from its surface travel far into space. We call this process the solar wind. Solar storms, on the other hand, are very violent eruptions. And a coronal mass ejection, or CME, is the most dangerous because it has the potential to bring our high-tech society to its knees. Today, we'll find out how bad ACME could be and what astronomers are doing to keep an eye on our star to try to predict when they might happen. Step back in time to 1859. First, in Victorian Britain, it was okay for a gentleman to be interested in solar astronomy. And one man did it in a very good way, Carrington Richard Christopher. We don't know what he looked like, though, because there are no known portraits of him. Carrington learned many important things from what he saw. He saw that different latitudes rotated at slightly different speeds, which meant the sun wasn't a solid body, but a fluid one. But he also saw that sunspots could be the start of a solar storm. On Thursday, September 1, 1859, there were no clouds in the sky in the morning. So Carrington was doing what he always did, which was to look for sunspots. He was using his telescope to project an image onto a screen. At 11:18, he saw two brilliant beads of blinding white light appear in what Carrington calls a kind of conflagration. Stranger still, they were gone after 5 minutes for no clear reason. Carrington had seen a coronal mass ejection, which was a huge magnetic explosion, a huge cloud of charged particles that are thrown off the sun's surface. After 18 hours, the Earth was hit by an electromagnetic storm. People started calling it the Carrington event. At the time, everyone was talking about the beautiful aurora, which could be seen all over the world. Even though a few telegraph systems went a little crazy because of power surges, it didn't have much of an effect on everyday life. Don't forget, though, that this was 20 years before the light bulb was made. That was in the past. Things would be very different right now. Coronal mass ejections are common, but they can be different sizes and move in different directions. So the question is, what are the chances that something like what happened in Carrington will happen today? And how would it change things? So, what is going on at the sun, on the surface of the sun, when we talk about the solar wind and space weather? The sun is made of magnetic fluid, and when that magnetic fluid rotates, it twists and distorts the magnetic field. A twisted magnetic field stores energy, which can lead to eruptions, which are called mass ejections. And these explosions are huge, sending out 1 billion tons of material at 1,000,000 miles per hour. So, we want to know where these things are going, because if they move toward Earth, they could affect the technologies we use. There's a very famous event in Quebec in 1989, where some power systems were disrupted for many hours in October. We've heard about the Carrington event, which happened in the 1800s. What would happen if it happened today, and how would it affect us? If we think about what we use satellites for now, we have GPS spacecraft that help us find our way, communication satellites, weather satellites, and even the stock markets are linked in some way. But we also have bigger power grids and a lot of wireless technology, and we don't know how they will react. How likely is it that something like the Carrington event could happen again? We know that the sun can still make these things happen. In 2012, there was an event that luckily didn't come toward Earth, but it did pass over one of the spacecraft we use to watch the solar wind. And it pushed all the sensors on that spaceship to their limits. So from what we've learned, we think that was at least as powerful as the Carrington event, and maybe even more so. It's just a coincidence that a big CME and one that's headed toward Earth both happened at the same time. And that's mostly just a matter of luck. We either get one or we don't. And how do we do with making predictions? Can we predict what the sun will do in a week, a month, or a year? Once ACME is up and running, we can start making predictions so that we can figure out how big it is, how fast it's moving, and most importantly, where it's going. All of this sounds very scary. Space weather is a problem, and the UK government knows this. The National Risk Register lists it. It's about as bad as a pandemic of flu. So, the people who make spacecraft are trying to find out what the most extreme conditions are in space, so they can make them so that they can handle those conditions to a certain degree. Both NASA and ESA are getting ready to send satellites into space that will get closer to the sun than ever before. The MET office's Space Weather Operations Center opened in 2014. It is one of only 3 places in the world that can predict the sun's effects on Earth around the clock. So far, the sun has had almost no sunspots, and the side that faces Earth is not expected to have any more sunspots or CMEs that are important. So luckily, there isn't much going on right now, and things don't look too different in the long run. So spacecraft, satellites, power supplies should be safe for the foreseeable future. Trouble is, the foreseeable future in space weather forecast is, at most, just a few days. We still don't know a lot about CMEs, like where they're going, how big they are, or when they might happen in the future. 2 new solar probes will get closer to the Sun than any other spacecraft has ever done. The Parker Solar Probe was supposed to be sent into space, and its destination will be close enough to the Sun's surface to fly through the source of the most energetic solar particles. The Parker Solar Probe is an exploration mission that will measure the gas and magnetic field near the Sun to figure out why this stuff is spreading out into the rest of the solar system. And this, the Solar Orbiter from ESA. Solar Orbiter might find out how sunspots, flares, and coronal mass ejections on the Sun's surface are related to the solar wind. Solar Orbiter's success will be very important for our understanding of how the Sun works. We think that the Sun's magnetic field is made in a way similar to how Earth's is, but it is much more dynamic and changes all the time. We have an 11-year sunspot cycle during which the Sun's magnetic fields move towards the poles and the polarity changes. On top of that, the magnetic field goes out into the solar system and flows over all of the planets. Solar Orbiter will measure these magnetic fields for the first time, and it will also give us the chance to watch the magnetic fields move to the Sun's poles. To do this, Solar Orbiter will take pictures of the Sun's atmosphere and measure the number, speed, and temperature of the particles moving across the space between the Sun and Earth. But the magnetometer, which is made to measure the tiny magnetic fields in space that are carried by the solar wind, could be one of the most important and sensitive instruments. The Sun is ever present in our lives. It gives us light, warmth, and even life itself. For Richard Carrington, who was the first person to record ACME, it was just a strange event. But now we know that these things can do a lot of damage to the world we live in. With new satellites and more observations, we might be able to learn more about these events and predict when the next coronal mass ejection will happen. Nothing existed at the outset. After then, the cosmos began to take shape some 13.7 billion years ago. How this came to be, or if there was ever a time before, time is still a mystery. Yet, physicists have pieced together an approximate timeline of significant events in the cosmos's existence using telescope data and models of particle physics. From its beginning to its inevitable demise, we examine key points in the evolution of our universe here. Welcome to the Endless Universe. If you are interested in amazing videos about the universe, be sure to subscribe to our channel to stay updated. The Big Bang. The Big Bang is a moment in time, not a location in space, from whence all else unfolded. To be more precise, it's the first second of time, the point in history from which all other seconds have been measured. The Big Bang, despite its common name, was not an explosion, but rather a time when the universe was incredibly hot and dense before space began to expand outward in all directions simultaneously. The Big Bang scenario suggests that the universe was an infinitesimally small point of infinite density. However, this is merely a convenient way of expressing that we don't know for sure what happened at that time. We now understand the cosmos to break down at the Big Bang because mathematical infinities don't make sense in physics equations. Cosmic Inflation Era. The next cosmic confab was to rapidly expand in size. The universe may have expanded exponentially after the Big Bang, tearing off previously colliding parts of space. This period, known as inflation, is still mostly theoretical, but it has gained favor among cosmologists as a possible explanation for the striking similarity between distant parts of space. Attempts to detect this expansion in light from the early cosmos were reported in 2014. Nevertheless, further investigation revealed that the true culprit was nothing more than interplanetary dust causing interference. Quark-gluon plasma. The temperature of the early cosmos was between 7 trillion and 10 trillion degrees Fahrenheit, or 4 trillion and 6 trillion degrees Celsius, just a few milliseconds after the Big Bang. Quarks, elementary particles ordinarily contained within protons and neutrons, were free to move about at these temperatures. These quarks were combined with gluons, carriers of the basic force known as the strong force, in a primordial that pervaded the whole universe. In particle accelerators on Earth, scientists have replicated these circumstances. In both terrestrial atom smashers and the early cosmos, the challenging to achieve condition only lasted for a few fractions of a second. The early epoch. The subsequent period of time, beginning perhaps in the neighborhood of a few thousandths of a second following the Big Bang, was a period of intense activity. The universe chilled as it expanded, creating an environment conducive to the merger of quarks into protons and neutrons. The cosmic neutrino background, which has not yet been detected by scientists, was created 1 second after the Big Bang, when the density of the cosmos decreased sufficiently for neutrinos to sail across space without interacting with anything. The first atoms. Protons and neutrons fused together during the first 3 minutes of the universe's existence, creating the isotope of hydrogen known as deuterium, along with helium and a trace quantity of the next lightest element, lithium. Yet, this procedure ceased as the temperature dropped. As temperatures settled down 380,000 years after the Big Bang, hydrogen and helium atoms could join with free electrons to form the first neutral atoms. The cosmic microwave background, a remnant of this epoch first identified in 1965, was created when photons that had previously collided with electrons were able to flow without being disrupted. The Dark Ages. There was a lengthy period of time when nothing in the cosmos emitted any light. The cosmic Dark Ages refer to this time frame of around 100 million years. Because practically all of what astronomers know about the cosmos can be gleaned by studying starlight, this era remains exceptionally challenging to study. It's hard to piece together what happened if there are no stars to guide us. The first stars. The first stars were formed when hydrogen and helium began to compress into massive spheres, some 180 million years after the Big Bang, creating hellish temperatures at their centers. After the neutral hydrogen atoms in interstellar space were broken apart into protons and electrons by the intense photons generated by early stars and galaxies, the cosmos entered a period known as cosmic dawn or reionization. It's hard to put a time limit on reionization. As it happened so soon after the Big Bang, its signals have been masked by subsequent gas and dust. Thus, the most that scientists can determine is that it was finished by around 500 million years after the Great Bang. Large-scale structure. Almost 1 billion years after the Big Bang, supermassive black holes developed at the cores of merging early galaxies. Intense quasars, visible from 12 billion light-years away, switched on and began emitting their bright beams of light. The universe's middle years. Throughout the subsequent few billion years, the cosmos underwent more evolution. Denser regions in the early cosmos drew more material due to gravity. A gorgeous filamentary cosmic web is the result of them slowly expanding into galaxy clusters and lengthy strands of gas and dust. Birth of the solar system. A yellow star with rings around it formed from a cloud of gas around 4.5 billion years ago in one galaxy. These accreted rings eventually became the 8 planets of our solar system, as well as numerous comets, asteroids, dwarf planets, and moons. Either the third planet out from the sun retained a lot of water via this process, or it received a deluge of ice and water from comets later on. Earth and humanity. Little primitive bacteria appeared on that third watery world between 3.8 and 3.5 billion years ago. These organisms arose and progressed into amazing marine monsters and enormous dinosaurs that fed on leaves. Some 200,000 years ago, upright beings emerged, capable of contemplating the vastness of space and learning about the universe's origins. The end, or not? It isn't the final chapter, of course. The future of the cosmos is still a mystery to physicists. It is dependent on our ability to accurately quantify the characteristics of dark energy, the unknown factor thought to be accelerating the expansion of the universe. All the stars and all the galaxies will have burned out, and even black holes will evaporate into nothing if the universe continues to expand forever, leaving behind a lifeless cosmos saturated with inert energy if this scenario comes to pass. Alternatively, the Great Crunch, a reversal of the Big Bang in which gravity triumphs over dark energy's expansionary force, will occur. The Great Rip, in which the cosmos rips itself apart, is another possibility if dark energy accelerates everything apart to greater and greater distances. Thanks for watching, and don't forget to hit the like button, subscribe, and turn on notifications for more content like this in the future. about galaxies. How did galaxies evolve into their present forms? Did spiral galaxies always have to be spirals? The answer is almost certainly no. Young galaxies are a mix of stars, gas, and dust. They are untidy and chaotic. They begin as chaotic formations, like the Whirlpool Galaxy, then over billions of years develop into more orderly forms. The Milky Way wasn't born from a single galaxy, but from a cluster of several. Our Milky Way originated as a collection of disparate formations, objects of varying sizes and shapes that gradually merged to become the galaxy we see today. Gravity is what binds the various components together. Over time, it gradually draws stars closer. They pick up speed and flatten out into a disk shape. Massive spiral arms gather stardust and gas. This process was carried out countless times during the course of the cosmos. While visually distinct, these galaxies share the fact that they all seem to circle the same central object. For a long time, researchers pondered what might possibly alter a galaxy's behavior. And they found out: a black hole. And not just any kind of black hole, but it's a supermassive black hole. The discovery of extreme amounts of radiation coming from the centers of certain galaxies was the first indication of supermassive black holes. Black holes in these galaxies are eating their surroundings, much like a giant Thanksgiving feast. The gas and stars are the supermassive black hole's dinner. Sometimes black holes consume their food so rapidly that they spew it out into space as beams of pure energy. They refer to it as a quasar, deep space. Through a process known as gravitational lensing, it warps the light. The existence of dark matter may be tested using gravitational lensing. As a ray of light from a distant galaxy travels towards us, its course will be bent around a huge collection of dark matter due to the latter's greater gravitational attraction. Some distant galaxies indeed seem stretched and warped when seen via the Hubble telescope. The picture distortion is due to the presence of dark matter. We can determine the density of dark matter by carefully examining the forms and degrees of distortion of these galaxies. Now more than ever, the importance of dark matter to the cosmos is undeniable. It's what makes galaxies form and stops them from collapsing. Even though it's invisible and undetectable, dark matter rules the cosmos. These galaxies seem to be completely alone. It's true, they are trillions of miles apart. But actually, they live in groups called clusters. And these clusters of galaxies are linked together in superclusters, containing tens of thousands of galaxies. The Milky Way's place in the cosmos remains a mystery. If you look at the overall image, you'll see that our galaxy is associated with a smaller group of galaxies, including about 30 members in total, and that our galaxy and Andromeda are the two largest members of this group. Further observation reveals, however, that our galaxy is embedded inside the Virgo supercluster. Researchers are now making maps of galaxy clusters and superclusters to better understand the cosmos. Galaxies are the immense star empires. The shapes range from enormous balls to intricate spirals. The problem is that they are always evolving. When we stare out into the cosmos, it's easy to assume that our galaxy hasn't changed in eons. It's not. The Milky Way is a dynamic galaxy. Over cosmic eons, its basic nature has been changing. Galaxies don't only evolve, they move as well. And sometimes they run into each other. The two galaxies will merge over millions of years when they collide. This kind of collision occurs all the time in the cosmos. Our own Milky Way is no exception. We are on a collision course with the galaxy Andromeda, and that's terrible news for the Milky Way. At a speed of around 250,000 miles per hour, our Milky Way galaxy will collide with Andromeda in about 5 billion to 6 billion years. It's all over for the Milky Way galaxy. If you could look out into space, you'd see the whole Andromeda galaxy hurtling toward us at a tremendous rate of speed. As the two galaxies interact, they both become more and more disturbed and closer together. There will be a dance of death between the two galaxies. Whenever galaxies collide, they release clouds of gas and dust in all directions. As galaxies collide, their combined gravity rips stars from their orbits and launches them into the void. As we approach doomsday for the Milky Way galaxy, it would be spectacular. The two galaxies will ultimately pass through one another and merge into a single one. The Milky Way and Andromeda as we know it will cease to exist, and Milkomeda will be born, and it will look like a whole new galaxy. There's no escaping what's going to happen. The question is, what's it mean for planet Earth? We may either be thrown out into outer space when the arms of the Milky Way galaxy are ripped apart, or we could wind up in the stomach of this new galaxy. Stars and planets will be pushed all over the place, so this may well be the end of planet Earth. Galaxies all over the universe will continue to collide. But this age of galactic cannibalism will eventually pass. Because there is an even more destructive force in the universe, a force that nothing can stop. It will eventually tear the cosmos apart by stretching everything to the point that galaxies are pushed apart from one another. Researchers have identified a new cosmic power. It's called dark energy. Unlike dark matter, dark energy has the opposite effect. It pushes galaxies apart rather than bringing them together. Dark energy, which we've only discovered in the last decade and which dominates the universe, is significantly more enigmatic. We don't have the slightest idea why it's there. What it's made from, we don't really know. We are aware of its presence, but beyond that, our understanding of it is limited. Dark energy is really weird. Things resist and are pushed away from one another as if space itself contained tiny springs. In the far future, scientists predict that dark energy will triumph over dark matter in the cosmos. And with that triumph, galaxies will finally begin to drift apart. Galaxies will eventually die off due to dark energy. It will do this by accelerating the expansion of the universe, forcing all galaxies to recede farther and further away from us until they become invisible and travel faster than the speed of light. Therefore, everything else in the cosmos will vanish before our own eyes. The remainder of the cosmos won't vanish today or tomorrow, but it may after 1 trillion years. Galaxies will be left alone in the void. However, this will not occur for an extremely lengthy period. The cosmos is doing well right now, and galaxies are creating favorable circumstances for life to exist. Without galaxies, I wouldn't be here. You wouldn't be here. Maybe not even life itself would exist. This is fortunate for us. The only reason why life has evolved on Earth is because our minuscule solar system was formed in the correct region of the galaxy. If we were any closer to the center, we wouldn't be here. Life in the center of a galaxy may be extremely hazardous. In point of fact, The proximity of our solar system to the core of our galaxy would render it so radioactive that it would be impossible for life to continue in any form. Too far away from the center would be just as bad. Out there aren't as many stars. We might not exist at all. We are therefore, in a sense, in the Goldilocks zone of the galaxy. Neither too close nor too far away, but just right. There may be millions of stars in the cosmic Goldilocks zone, where conditions are just suitable for life. Furthermore, if our galaxy can support life, then other galaxies should be able to as well. The cosmos is very large, and the really incredible part is that we continue to learn new things about it. Every time we believe we've figured out a solution to an issue, we uncover that it's really part of an even greater one. That's awesome. Our Milky Way galaxy and the galaxies beyond it are rife with mysteries and unanswered questions. Who would have guessed 20 years ago that we would be able to identify the black hole at the center of the galaxy? Who would have predicted 20 years ago that the astronomical community would accept the existence of dark matter and dark energy? We should be astonished to be alive at this particular moment in cosmic history, on this particular planet, on the fringes of this particular galaxy, with the ability to ponder questions and seek answers across the whole cosmos. Galaxies are born, they evolve, they collide, and they die. The Milky Way is a fortunate home for intelligent life. Our fate is intertwined with that of every galaxy. Ultimately, our fate rests in their hands since they are the ones who created us and are shaping our identities.